Okay, so hello guys, so welcome to our video. So in today's problem what we are going to say is problem number 3381 in Leetcode. So this is today's strike problem, maximum subarray sum with length divisible by k. So before going into the problem, let's read out the description which they have given here. So you are given an array of integers nums and an integer k. Return the maximum sum of a subarray of nums such that the size of subarray is divisible by k. So they have given the input and output examples. So let's say what they are coming to say. Let's say you are having an array like this, which is 0 1 2 sorry 1 2 3 4 5 and 6, sorry 5 and 6. So the value of given k value is equal to, let's say, consider 3. So now what we need to do is, they are asking the length of the subarray should need to be divisible by 3. The sum could be anything, but the length of subarray which you are taking to find the maximum subarray in the given array should need to be divisible by 3. So it is nothing but of either k or 2k, 3k, 4k and so on, which is either you take first k values, or else you can go for like let's say the value of k is equal to 3. The size of subarray could be 3, 6, 9, 12, which is multiples of 3. So if the given the k value is equal to 2, it will be 2, 4, 6, 8, which is multiple of 2. So this is how you can choose a subarray. Okay, and let's say if the given value is equal to 2. So for 2, there are how many possible subarrays you can create in this array? You can take 0, 1 as a subarray. Let's say they have given a k value is equal to 2 for this subarray. And what are the subarrays for this array? What are the subarrays you can able to create is 0, 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6. So these are the possible subarrays for 2. So hence they have given the length could be multiples of 2. You can take 4 also, which is you can say 0, 1, 2, 3, which is length of 4, and you can take 1, 2, 3, 4, which is again length of 4, which is divisible by 2. So let's say 2, 3, 4 and 5 and 2, 3, 4, 5 and you start from 3, 4, 5 and 6. And if you go for again one more, which is 6. So the multiples of 2 are 2, 4 and 6. So if you go for 6, you can also create a subarray size of 6, which is 0, 1, 2, 3, 4, 5, which is this is an subarray size of length is equal to 6, which is multiple of 2 again 1, 2, 3, 4, 5 and 6. So this is also a valid subarray, which is multiple of the length of this size is equal to 6, which is divisible by 2, so divisible by k here. So if you take the, now let's calculate the sum of each and every subarray, which is this is 1, and if you go here this is 3, and if you go here this is 5, sorry, and again if you go here this is equal to 7, and again if you go here this is equal to 9, and again this one is like 11, and again if you go here 1 plus 2 plus 3 is 6, and if you go here 1 plus 2 plus 3 plus 4 is equal to 10, and you go here you will be having 14, yeah 14, and if you go here you will be having 18, right, yeah 10, yeah 18, and if you go here what you have is 0 plus 1 plus 2 plus 3 plus 4 plus 5, which is 15 again, and this one will be 16, I think so. Sorry, 21, I think so. Yeah, let's check it out. 10, 15, 20. Yeah, 21. So these are the possible subarrays you can create out of this given array. So for this given array, these are the possible subarrays, which is multiples of 2. So for if you go for if k is equal to 2, size of 2, you can create this many subarrays and their sum is equal to this. And if you go for 4, you can able to create this many subarrays. This will be what say. So this is 4, which is again divisible by 2. And if you go for size of 6, you can able to create 2 subarrays. And again this is also divisible by k, which is 6 is divisible by 2, right? So that's what. So out of this subarrays, this subarray forms the maximum, right, which is 21. Then value of 21 should need to be returned. So this is what the problem which they have given. So what they are asking is, they will be giving you the array and the size of k. What you need to do is, you need to calculate the sum of subarrays. Hence the size of the subarray is divisible by k, and you need to find the maximum, which subarray gives the maximum sum. And either sometimes there could be some negative values also. So in this test case too, you can see there are some negative values has been given. So if you go for size of 4 for this, let's take this and analyze. So what they have given is -1, -2, -3, -4 and -5, and the size is equal to k is equal to 4. Hence what happens, you create -1, -2, -3 and -4. So this is an subarray, and one more subarray which you can able to create is -1, -2, sorry, -2, -3, -4 and -5. So if you go for the total, which is sum of this subarrays, this will be -10, and this will be like -14, right? So if you take this out of this 2, -10 is the maximum, and again, so -10 is maximum because it towards 0. So -10 is the closest to 0. Like comparing minus values, 10 is greater. Okay, so that is a simple math. So then 10 will be returned. So that is what they have done here. Okay, now what you are going to do is, if you see here, so for this the remainder is equal to 0, for this the remainder equal to 0, but when you doing this in array, you can't able to take the exact remainder value of 0. So for that, what we can do is, we create an array of size k, which is, let's say if the size of k is equal to 0, what you do is, you create a size of 2, which is 0 and 1. So it stores the minimum value which has this remainder, which means the size of that array remainder will be stored here. Let's say if the size of k is equal to 4, which is in this case, what you do is, you create an array value, sorry, you create an array which has 0, 1, 2, 3. So this, which is index value, this holds the minimum value that can be processed using this zeros index, which is the multiple of 2. Multiples of 2 will be stored here, and for this, multiples of 2 plus 1, a subarray which has a size of multiples of 2 plus 1 will be stored here. When it comes to 2, the multiples of k, which is multiples of k plus 2 will be stored here, and multiples of k plus 3 will be stored here. Let's say there is an array, like let's take some random array. The size of this array is 4, the given value is 4, so this sum will be stored here. Let's say we have one more value, size of this array is 5. If you modulo by 4, what happens is, so 5 modulo 4, you get 1. So sum of this array will be stored here. Let's say you have one more value. Again, what happens, the size of this is 6, modulo by 4, 2, you will be getting 2. So this 2 will be, the value of that sum will be stored in here. And for again one more value, so again if you do that modulo, what you get is, the remainder is equal to 3. So this value will be stored here. And if you see here, you won't get only one subarray which gives you the remainder 0. The length of you'll be having multiple of subarrays which length is equal to something that gives the remainder of 0, 1, 2 and 3. Then how would you know which subarrays value should you need to be stored here? The minimum we will be storing here. The minimum will be storing here because they are asking for the maximum. What happens is at last we accumulate the sum and we minus and we return, right? So for that we need the minimum value. So because if you segregate the minimum value, you will be getting the maximum value. So for that, okay, now hope you guys have the clear idea. Now let's jump into the code and try to understand this. Okay, okay, so let's create an long array which is this is considered as prefix. So prefix what's it, minimum prefix. Okay, so for this minimum prefix, what you have is we have the new long of k, which means this is where we will be storing the values. So we created a size of array, a size of this. Okay, and again we will be having a, so hence they have said the value could be greater, right? So we need to have the maximum value to store in this array. So instead of again and again taking this, okay, we can do that. Okay, for int I is equal to 0, I is lesser than k, I plus plus, what you do is you say min prefix of I is equal to like long dot max value. Hence we are storing it. Hence we are storing the minimum value, we declaring it as max. Okay, so if you get a value while we comparing that with this max value, that value will be like lesser. So further, and hence it starts from 1 because for 0 we consider there will be like 0, the value, the sum which we are having is 0. So that's why we are starting it from 1. Okay, and now let's have the long which is prefix. So it has the sum of the elements till the I, and after that what you have is we have the answer which you want to return, which is long of, let's consider this result which we are going to return. So this result is equal to long of min value, because we are going to accumulate the maximum sum. So if you start from min, so that will be greater for you. And after that what we do is we done a int I is equal to 0, I is lesser than nums dot length and I plus plus. So inside this is what you do is you say prefix plus equal to nums of I, which is you are adding the value, right? We are like accumulating the sum until that index. Okay, after that what happens is you say that you will be having a mod, int mod operator to check the mod. Okay, int mod is equal to I plus 1 modulo of k. So this is to get the remainder, because 0, 1, 2, so let's say if the given k value is 3, it will be 0, 1, 2, again for 3 it will be 0, right? So 0, 1, 2, again 0, like that. So for that, okay, so we check if the previous we don't have any prefix, sorry, prefix of that mod. If the prefix of that mod is not equal to long dot max value, what it means is n value has been updated, which means there is a value there. So then what you do is we say result, we need to update the result. So using the max, result is equal to math.max of result, comma, that prefix minus min of prefix of that mod. I think there is, so we do that, and after doing this, what we do is we update the mod value, which is min of prefix of that mod. So if that mod has been having not updated, what we need to do is we need to update that value to the minimum value. So math.min this minimum prefix of that mod and the prefix for this. Okay, we check this both, and if this prefix is lesser than that, we will update this. After that, we return the result. Okay, now let's check it out. Okay, now let's submit this. Okay, there you go. So for today's class we have completed this. So if you liked our video, do a like, share and comment also, and don't forget to subscribe. Okay, yeah, bye.